LLM like ChatGPT and Gemini are great, but they does not know your business. Hi, I'm Nirmit Patel and today I'll demonstrate how to build a RAG powered chatbot that pulls accurate answer directly from your internal company data. As an iOS developer working for Costco, for this hands-on project, I have integrated a chat view directly into the Costco app to show real-world use case. And just to mention, we are not going to use any machine learning framework. We will be implementing this using Swift for iOS and TypeScript for Firebase Gemini. Let's start the demo. Let me ask the question on the products available at the Costco. So I'll ask what is the cheapest MacBook available. So it did answer from the product which we uploaded on the Firebase after scrapping the Costco website. So I scrapped some electronics such as laptops and refrigerators and other electronic items and uploaded to Firebase. And from there, when I asked what is the cheapest MacBook available, it searched the Costco internal data and returns the result from there. It keep context of previous questions asked as well. So let me ask another question related to already I asked question before. Like I asked for the cheapest MacBook available. Now let me ask, is it available in silver color? Let's see what it answers. Yeah, I mean it is answering in human language completely like other LLMs. Yes, the cheapest MacBook is available here in silver color. And if you click on it, I did mapped here and it's landed you on the MacBook page. So these are the example where LLM or our RAG or our chatbot is searching the product databases available, but it can hit API also. So like in Costco app in warehouse, you can check whether the some product is available in warehouse or not, and for that we have an API. So now this chatbot can hit that API to answer the question user asks. So suppose I'm asking, like, there's an Indian dish called pani puri, is it available uh, in my warehouse or not? So let me ask, is pani puri available at my warehouse? So when you install the Costco app, you have to select the warehouse. So this app knows what is my warehouse, and uh, it will hit that API and it will get the result whether is it available or not. Yeah. So pani puri is available at warehouse at 248. Or you can ask in another as well, like, is pani puri uh, available in stock at my warehouse? Or you can give some warehouse number or address, it will answer for that also. And yep, it is saying that pani puri is available in stock at your warehouse. So like, I mean, it does not depend that you have to follow some format. It's simple like other LLMs. You ask question in natural language, it will understand what user is asking, and it will search uh, the result either from the API or from the product database, or I mean internal product database. And we can ask some weird question or other question as well, like suppose any refrigerator available which opens from right to left. So like this information is not available in the product which we have uploaded. So like it can answer the other based on other parameters which is already available in the database, like smallest refrigerator available. And it will show us the smallest refrigerator available in the Costco. Let me show you the database from where our chatbot is getting the information. So uh, here is the data we uploaded, uh, which we uploaded from the scrapping the Costco website. So each product we make a entry for each product, but the searching logic for chatbot is a different, because this data size can be huge and searching can be slow. So what we need to do is we need to perform the vector search from the search string entered by the user. We'll cover this vector search in detail, but for that, generally for this RAG technique, we have to use the vector database, and Firestore support the vector search for the existing database. Also, we can see the functions which mobile app is calling to uh, to get the result. So we have created two functions. One is update docs and one is Costco LLM. We'll see the code of these two functions in detail in few minutes. I'll just explain what these functions do. So update docs is updating the vector binding in the database. So suppose you enter a new product here, so it will add the vector binding. So this embedding, right, this through which this search is getting faster, is done is done by this function. So it will convert the all information into vector and save it. And similarly, the user enter the text, will convert it into vector, and this vector search will be done. And it has a algorithm, various type of search algorithm is there, like nearby or cosine, uh, and based on that, the search, like this product will be picked up and passed to the LLM model. So this is the update docs, and this Costco LLM method is like giving all this information to existing LLM to answer the question from the search result. Now let's discuss the backend code. You must be expecting huge code at backend, but it is simple. Three functions. First one, to create a vector from the stored data. To return the second one is to return the result for the question asked by the user. Third is API call to get the availability at the warehouse. We'll go all three functions one by one. Now to create a vector embedding, uh, this code is getting executed. So basically, this call, we are calling a method on document return. This will be called, this is a part of Firebase package. Uh, Here we import, sorry, Firestore package, here we import. And this is a callback of this method. So that will be called when someone update or edit the document in the Firestore. So suppose if I add new product in the my Firestore database, this method will be called, and this code will be executed. And what it is doing is the major part of this code. I'll share this code, or the complete code and the dependency package.json on the GitHub, and we'll share the link uh, in the description. So this will convert. So suppose you enter some product detail, it will convert into vector data and save it. Like it will save it vector embedding in the same document. But the question is why we need vector embeddings. So when we say that vector embedding, we are converting the text or the product data to its numerical meaning value, so that semantic search can be performed on this data. So suppose if user enters the word which is similar in meaning to the product document which we are whose vector we are calculating, then this whole context will pass to LLM, and our LLM will answer the question asked by user from this data. Now let's look at the function returning the answer to the user's question. And like this is the most important part of whole demo project. So the function is this one, Costco LLM flow. I did show you in Firestore, sorry, in Firebase also. So this is a function. We defined the name of the function Costco LLM flow, and this will be called every time when user asks some question. And from the client side, few few question will be passed here to get the context of the whole chat. So here, like they can, it's a on the client side they can decide how many question they need to send. And so once a user call this function, it will be coming here. We will be fetch the previous messages, and now uh, this is a search where we are doing the vector search. So uh, we did define a Firestore retriever uh, to get the context of the question. So suppose you are asking for the cheapest laptop. So this will be passed to this Firestore receiver, and uh, yeah, this is the Firestore receiver, and it will search our product database and find the, like we can define what type of search we need to do. Is there are multiple search algorithms available. We are doing here cosine search, so it will try to find the all products similar to laptop, or yeah, I mean it will do vector search and get the all the products which is similar to laptop, and will be get here, and it will be passed along with the prompt. There is a prompt which user get as well as the history. Now we have the products also, which may be similar to uh, the product which user asked. And now we are creating a prompt in which we will be passing that context, or you can say the product list which we have fetched using the vector search, as well as some instruction to LLM model, and it will return us the answer and will return that answer to the client. So and most of the programming is done in the English, easy English language here. So what we have defined is, if user is asked about stock or availability or product inventory in the warehouse, you need to call a method get warehouse inventory, and we have defined this method. We'll cover this method in next section. And if users search for the nearby warehouses, uh, and we will be passing the coordinate ID, and there is one more API to search the warehouse using the coordinates. So we have defined this method as well. And in case of error, if user asks some question which is not related to Costco products, so return some generic answer. And we did define like in which format you should return the result, so client can so basically in on the client side we need to show the carousel with the product. So we are creating a JSON and passing in that. In that JSON we are creating products, warehouses, so user can ask for warehouse also and products also. So we are returning this product, warehouse, and the small description for the answer, like the title answer which user asked it. And we are passing this context. So this context contains the product list. This contains the past four messages. So suppose you ask a message, what is the cheapest MacBook available? And then in the next question you ask, is it available in silver color? So this model should understand that you are asking for the cheapest laptop which is available in the silver color. So to make the context, we are passing last few messages, uh, and we can set how big context we made, because we have to do the trade off. If we pass the more question or full history, we'll be increasing our token size. So to keep the balance, we need to decide how many questions or we need to pass in the LLM model. And here is the main things which I was doing. In prompt, we have added the context as well as the previous questions, and and the prompt which is asked by user. Sorry. And this method will call the, so basically I passed the Gemini. Uh, uh, I did decide the model Gemini here. So if you see this AI object, so basically we created this AI as a gen kit, and we need to pass the API key here. and the model we want to use. And if you are using GenKit, it does not mean that GenKit is from Google, so you have to use Google models only. No, we can use any model. We can use ChatGPT, we can use DeepSeek, we can use uh, we can use Cloud, and this string is available. We can get it from the documentation and use the model which we want to use. We don't have to be use Gemini specifically. Now coming back to this function, we already given the output schema where we defined the JSON how we want it. So this is the output schema. We can define it like how we want the output. So client can render the UI from this, and once we receive the output, we are returning output to the client. Like from here, the execution of this cosqllm function will be over. Now let's see uh, how we are calling the warehouse. So in the prompt we have written that in case user is asking for the warehouse availability, call the get warehouse inventory. So we have defined this method also. Yeah, this is the method. So we are this is called as a tool. Like some answers can be get from the tool, and to API is one of the tool. So if user is asking the inventory, this GenKit can call the API on the AI's behalf to get the answer and to return it to the user. So LLM model will understand, okay, it is asking for the availability in the warehouse or the inventory in the warehouse, and in the prompt it is given that call this method. So GenKit will call this method, and it will pass the ID or the text search text. I have given this URL which I have scrapped from the Costco web, and uh, I did pass it, and it is returning if the product is available there or not. Now let's see the iOS code. So it's a simple. We are simply calling. We simply implemented the chat UI and a function. Uh, so which calls an API, which is like our Firebase GenKit API, which we made in the Firebase. It and get the result and show it in the UI. So like the iOS is like making the chat UI in iOS is pretty common. We'll go through the function which we are calling and get the response and showing it there. So basically we are calling this method Costco LLM which we have created, and here we are passing the previous messages which we are getting from the window, uh, and the prompt is a text which users enter, and creating the request body, and creating the request object, and waiting for the response. And on getting on the response, we are trying to pass the JSON. uh, we already discussed the JSON which will be sent when we were covering the backend GenKit code, and we are passing it and showing the result on the window. Please go through the complete code from the link I'm sharing and try to implement the same by your own to get started with RH in the easiest way. And we did not use any complex model training or refining LLM or creating LLM model using machine learning framework like PyTorch or TensorFlow. I hope you find this tutorial interesting. Thank you.